Good day and welcome back to the Johnson Space Center as our pre-flight briefings continue for the STS-135 ULF-7 mission to the International Space Station. This is the mission overview briefing, and with us today are the two gentlemen who will preside over the final flight of Atlantis and the last flight in the Space Shuttle program's history. To my left, Kwatsi Alabaruho, the lead Space Shuttle director, Flight Director for STS-135, and to his left, Chris Edelin, the lead Space Station Flight Director for ULF-7. And we'll start off with Kwatsi.
Thank you, Rob. Good afternoon, good morning. It's my honor to be here to talk to you about the details of this final flight of the Space Shuttle Atlantis, the STS-135 mission, her cargo, and her crew. The primary objectives of this mission, of course, as you heard from our program management, are to bring the multi-purpose logistics module to the International Space Station, to provide some resupply and logistics to set the space station up for continued operations through the end of 2012, as well as to return a failed component, the external control system, thermal control system pump module from the ISS, and to deploy a special payload, the robotics refueling mission module, which is a technology demonstration payload that has been developed by Goddard Space Flight Center. We'll have more details on this aspect of the mission in the moments to come. If we could have the still of the STS-135 crew. We have an awesome crew for this mission, veteran space flyers commanded by Chris Ferguson, retired captain, the U.S. Navy, veteran of space flights, STS-115, STS-126. Also pilot Doug Hurley, who's Colonel, U.S. Marine Corps, and a veteran of STS-127. You have Dr. Sandy Magnus, who is an experienced shuttle and space station crew member, previously flown on STS-112, STS-126, and she was flight engineer on Expedition 18 and returned home on STS-119. And then also we have veteran spacewalker Rex Walheim, who flew on STS-110 as well as STS-122. The crew patch for this mission, which you can see in another still, is a very special one, very symbolic. It symbolizes and pays tribute to the legacy of the Space Shuttle program, as well as the contributions of the civil servant and contractor workforce that have contributed to the Space Shuttle. You see Atlantis there in the center of the patch, embarking on her mission, set over elements of the NASA emblem, and particularly powerful is the Omega, which is prominently featured in the image, to symbolize the end of the program, as Omega is the last letter of the Greek alphabet. And I think this patch really summarizes the legacy of the shuttle program, as well as the significance of this particular mission. Let me tell you a little bit about the flight director team that will be supporting Space Shuttle operations on this flight. As the lead shuttle flight director, I'll be on the Orbit 1 team, as is traditional. We also have Ascent Flight Director Richard Jones, and you'll see a picture of him there in still photograph. Working Orbit 2 will be Flight Director Rick LeBrode, who's also highly experienced Space Shuttle Flight Director. Our planning shift will be presided over by Senior Space Shuttle Flight Director Mr. Paul Dye, who has flown more Space Shuttle missions than anyone currently in the office. And then our Team 4 Flight Director, this is the gentleman who will help lead special support teams in resolution of any intractable problems, which of course we hope we don't have, and that'll be Mr. Gary Horlocker. He'll be presiding over our Team 4. And then Entry Flight Director Tony Sakachi, he will handle the team that will be presiding over Atlantis' final deorbit entry and landing. So this is an excellent flight director team to go along with an outstanding crew that will very capably perform all of the mission objectives for STS-135. And I personally am very excited about working not only with our crew, but also with the other flight directors and flight controllers that will be supporting the mission. Just to show you how Atlantis' payload bay is configured, let's have the first video, and you can see the various elements of the payload bay. Here you've got Atlantis' payload bay in its final configuration. On the forward end of the spacecraft, you'll see the orbiter docking system, which will allow it to mate to the International Space Station. We also have featured prominently the shuttle remote manipulator. And on the other side of the spacecraft is the orbiter boom sensor system, which will be used to inspect the thermal protection system of Atlantis. Underneath the OBSS, you see a canister which will be used to deploy the picosat solar cell experiment after undocking. And there, of course, is our cargo carrier, the multipurpose logistics module, and aft of the MPLM we have the LMC lightweight MPES carrier, which I'll give you some more detail on. You see the LMC is essentially a truss which is specially equipped to carry cargo. On the underside of the LMC is the robotic refueling mission. It's a cube-shaped orbital refueling demonstration payload. And then you see where the failed ETCS pump module will return after we retrieve it from the ISS. That will fly home in Atlantis' payload bay. So that's how the spacecraft is configured. And we are highly confident that we'll be able to get all of the cargo deployed properly. And we have an excellent team that's worked hard to be able to do that. Just to give you an overview of the activities on the mission, starting with Flight Day 1, we'll be conducting our normal launch, ascent imagery activities as you've come to expect. We'll be deploying laptops to provide access to special files, updates to the flight plan, changes to the execute package, and procedures that we'll be updating for the crew during the mission. We'll also be activating the robotic arm and checking it out, making sure that it's prepared to conduct the thermal protection system inspections on the following day. And then we'll do our standard OMS pod survey. On Flight Day 2 is when we'll conduct our TPS inspections, and we have another video to show you to illustrate how that will be done. Here you see the robotic manipulator grappling the orbiter boom sensor system. The orbiter boom sensor system, the OBSS, will then be maneuvered into position to start survey of the starboard wing. There, the various sensor packages on the OBSS, which include high-resolution still camera, a laser range imager, as well as a video camera, will sweep over the critical surfaces of Atlantis' thermal protection system, looking for any imperfections, any damage that might have been caused by ascent debris, or anything that might compromise Atlantis' capability to perform a safe re-entry. After inspecting the wing leading edge and also areas of the payload bay door, the OBSS will inspect the nose cap, which is also made of the same reinforced carbon-carbon material that's on the leading edge of the wings. Once that inspection is complete, the OBSS will then move to the port wing and conduct similar inspections of the thermal protection system there, again looking for imperfections, looking for orbital debris damage, ascent debris damage, and anything that we might need to go address and remediate. We'll conclude by inspecting the port payload bay door, as well as some of the areas where umbilicals were attached prior to launch. We expect this inspection to take most of the day on Flight Day 2. As Mr. Shannon alluded to, it will be challenging to get through that inspection with the reduced crew complement. But this crew has practiced considerably to be able to develop a flow or a routine, if you will, to where even though they have fewer hands available in the shuttle, they'll be able to get through these inspections with confidence and within the time frame that's been allotted for them, and then berth and stow the OBSS as you see there. After the conclusion of the Flight Day 2 thermal protection system inspections, the crew will complete checkout of the various tools that assist them with rendezvous and docking. And the very next day, they'll engage in Atlantis' final rendezvous and docking with the International Space Station. We have a video to illustrate the final phases of that rendezvous and docking. We expect Atlantis to arrive on the R-bar, or just underneath the space station. ISS crew members will then prepare to take photographic high-resolution imagery with 400, 800, and also 1,000 millimeter lenses. This will help us evaluate other areas of the Atlantis' thermal protection system that we were not able to see with the orbiter boom sensor system. And it'll also help us assess the capability of the spacecraft to perform a safe reentry. Once Atlantis' final RPM maneuver or R-bar pitch maneuver is complete, Atlantis will maneuver to what we call the V-bar, which is basically putting it out in front of the space station. And then Commander Chris Ferguson will guide Atlantis to her final approach and docking with the ISS. Again, with the reduced crew complement, the deployment of the crew on the cockpit will be a little bit different, but they've been able to get a good flow, and we've rehearsed this rendezvous scenario several times with the crew. And we are excited to engage in this final rendezvous with the International Space Station. We think it'll be a great day, and we think we'll get some great imagery of the shuttle on her final approach. After hatch opening, we'll hand off the OBSS to the space station robotic arm. We do have a video of that, a brief clip that we'll show you. And that's basically to get the orbiter boom sensor system out of the way so that when we get ready to unberth and install the MPLM, we'll be able to avoid any risk of colliding with the structure of the OBSS. So essentially, the station's robotic arm, will grapple the OBSS and hand it off to the Space Shuttle robotic arm, where the Space Shuttle robotic arm will then essentially move the OBSS to a benign camera viewing position where that part of the boom will be well clear of any structure that might be in the way as the MPLM is removed from the payload bay and installed. At that point, we'll begin the docked phase of the mission and all of the objectives that are encompassed in that phase. And I'll hand it over to my associate, Mr. Chris Edelin, to tell you more about that.
Thank you, Quatsi. First, let me say I think it's quite fitting that the final flight of the shuttle, is exactly the type of missions that its designers originally intended, and that is to service a manned laboratory in low Earth orbit. This is the 37th flight of the shuttle to the space station, and the first flight was back in 1988 when Endeavour delivered the first U.S. element and attached it to the first Russian element that had been launched. So here we are, 13 years later. The space station is now over 900,000 pounds. It's bigger than a football field from end to end. It's home to a multinational crew of 6 performing cutting-edge research in biology and medical science, astronomy, physics, fluid and material science. So the space station largely has been lifted into orbit by the space shuttle. It's been assembled by spacewalking crews from the space shuttle, and it's been resupplied by the space shuttle over the years. So the space station literally would not have been possible without the contribution of the space shuttle. So again, the main purpose of STS-135 is logistics, bringing up the supplies that will provision the space station through the year 2012. That's a key date because our commercial cargo providers are going to be coming online in early 2012, and by providing the supplies we need to get through all of next year, that will provide a little bit of a breathing room for the development as those companies and spacecraft enter their challenging flight test phase. And of course, our crews will continue to be rotated to and from the space station using Soyuz spacecraft provided by the Russians. We've been doing that exclusively on Soyuz for space station crews for the past couple of years, in part because the Soyuz serves as the lifeboat for the crews when they're on the space station. So let me introduce you to the current residents of the space station. If you can put the graphic up, please. This is the crew of Expedition 28 currently on the station, and they'll be the crew members greeting Atlantis when she arrives in July. Starting from the left is Satoshi Furukawa of the Japanese Space Agency. He's a medical doctor, and Expedition 28 is his first space flight. Next to him is NASA astronaut Mike Fossum. He's a retired colonel from the U.S. Air Force. He's an Eagle Scout and an active Scoutmaster here with a troop here in the Houston area. Mike was mission specialist on STS-121 and 124, and he has done 3 spacewalks on STS-124. And next to Mike is Ron Guerin. He's a former F-16 pilot, and he was his previous flight experience was as mission specialist on STS-124 with Mike Fossum, and he actually performed 3 of those spacewalks with Mike. Next to Ron is cosmonaut Alexander Samoyakatayev. He's a lieutenant colonel in the Russian Air Force and a flight engineer on Expedition 27 and 28. Then next to him, second from the right, is Sergei Volkov. He's also a colonel in the Russian Air Force. He's the former commander of Expedition 17 back in 2008, and he's also the commander of the 27S Soyuz vehicle that he flew up with Ron and Mike, and they arrived at the space station in early June. And finally, on the right is the Expedition 28 commander, Andrei Borisienko, and he's the former flight director from the Russian Flight Control Center in Moscow, and he's been supporting space station operations since early April. And he's the commander of the 26S Soyuz with Ron and Alexander, and I believe I have a correction on Sergei Volkov is the 27S commander, and he flew up with Mike and Satoshi. So that's our crew on the space station. They've been very busy the past couple weeks preparing for STS-135's arrival. They've been gathering the cargo that's going to be returned in the multi-purpose logistics module. They've been checking out their spacesuits. They did a dress rehearsal last week to assess the fit of their spacesuits and practice some of their procedures. They've been doing a lot of self-study to prepare for the spacewalk. And for example, this morning, they swapped out the air conditioner in Node 2, the Harmony module, in order to prepare the heat exchanger in that air conditioner for return on the shuttle. So supporting the space station crew will be 3 flight control teams in the space station control room. I'll be leading the Orbit 2 team. We'll be running things from the midday during the crew day towards their pre-sleep time frame. If we put up the graphic, Jerry Jason is our Orbit 1 flight director. He'll be leading the team during the crew morning from a couple hours before wake up until the midday meal. And then Courtney McMillan is our Orbit 3 flight director. She'll be in charge of the planning team. They'll watch over the vehicle while the crew's asleep at night and replan the next day's activities. So back to the timeline. Where we left off was the end of flight day 3. We had the shuttle safely docked, the OBSS transferred to the shuttle arm, and now we can get into the joint mission. Flight day 4, our first full joint day of the mission, will commence the cargo transfer operations. We'll be transferring first about 2,100 pounds of cargo from the middeck of Atlantis over to the space station, and then we'll prepare to install the Raffaello multi-purpose logistics module on the station. Now, the type of cargo that we're bringing up is just the type of thing any of you would plan for if you were in charge of outfitting a research station at some remote location, such as Antarctica. We're bringing up crew supplies, such as food and clothing. We're also bringing up critical spare parts for any unanticipated failures, and we're also bringing up science supplies and experiments. So just to run down through some of the specific numbers, in the multi-purpose logistics module, we'll be carrying up 8,150 pounds of cargo, and the totals, including Raffaello and the middeck, for food and crew support items is 2,680 pounds, and 4,340 pounds of spare parts for the station, and 1,780 pounds of science gear for utilization. And just a couple specific examples there. One of the new spare parts that we're bringing up to enhance our urine recycling system is the Advanced Recycle Filter Tank Assembly. Our current filters that are used to filter urine and turn that into drinking water that can be used over and over again these are throwaway filters that they're used only once. They're either discarded or brought back to Earth and refurbished. The Advanced Filter Tank Assembly will allow us to reuse the hardware over and over again. We'll essentially take the brine, the yucky stuff, and offload that into disposable canisters or the waste tanks of Progress spacecraft, and then dispose of that. So essentially, the advanced RAFTA, as it's called, will allow us to decrease our reliance on ground resupply. Another example is the Amine swing bed. This is a CO2 scrubber. It's an advanced demonstrator for new ways to scrub carbon dioxide from the air. It's to demonstrate technology that we'll need for future spacecraft. And also, we're bringing up an ultrasound machine. This will be used for studies to determine the effects of microgravity on the astronauts' physiology. There's a lot of applications for this study because the astronauts' bones and muscles tend to degrade over time, similar to how what occurs to people on Earth when they're subject to bed rest or the elderly with osteoporosis. So we're bringing up a lot of really interesting gear for technology demonstration and scientific study. So next, I'd like to show you a view of the multi-purpose logistics module. We have a video of the MPLM at the Space Station Processing Facility at KSC. The MPLM is built in Italy. It was last flown on STS-114 back in 2005. And you can see inside the module there are attach points where standard-sized racks are mounted. And you can see the racks across the top of the view there. We'll be flying 3 different types of racks. They're each about the size of a refrigerator. And in this graphic, the first type is the resupply stowage rack on the top and bottom there. Those are essentially drawer-type racks used for small items such as food and clothing. You can think of that essentially as your dresser drawer in your bedroom. On the sides there, we have resupply stowage platforms that are used to hold oversized cargo, specifically our spare parts. And then at the top there was a view of another flat supply platform, the International Standard Payload Rack, which again is used for oversized payload type items. On the end cone, we're going to have 12 crew transfer bags mounted. So again, a view back inside the MPLM, you can see some of the transfer racks that are mounted in the module, again, that are used to hold the cargo. Here's an example of a cargo transfer bag getting ready to be loaded in by the technicians. And that's the end cone of the logistics module. And we have several, again, 12 of those bags will include food, clothing, GPS antennas, and some spare printers. Here's an example of the resupply stowage platform. You can see the backside of that platform is loaded with cargo. Again, inside those transfer bags are spare parts. They're packed in foam and then put into a Nomex transfer container. They're secured onto the platform, and then a special machine loads it into the MPLM. Once it's, and just to give you a couple of specific examples of the spare parts there that are going to be on the vertical platforms are, we have a new distillation assembly for our urine processor. We have a new gyro for the TVIS treadmill, and a new charcoal bed coming up for our air purifier. And here's the technicians installing one of the spare parts on the front side of the rack. And on orbit, basically, it'll be the opposite process. The crew will unload the front side first and then tilt the rack to access the back side. Here's our crew at Kennedy Space Center earlier this month. They came down to inspect the module and the cargo and to review their transfer plan. And on June 13th, the module was completely loaded, hatch was closed and sealed up, and then it was inserted into the payload canister for the trip to the launch pad. So on June 20th, Raffaello was delivered to the launch pad. You can see Atlantis there. It was lifted up into the rotating service structure, and this is a really neat process because the module is extracted from the payload canister into the room there in the backside of the rotating service structure, and then that entire gray structure is rotated over to cover the payload bay, and then in a clean environment, the shuttle payload bay doors are opened, and the MPLM was transferred into the payload bay. So that's where Raffaello is right now, awaiting launch. The weight of the logistics module is 25,400 pounds. That's the second heaviest MPLM that we've launched. But we are carrying the most cargo on this flight than we've ever carried before in an MPLM. So next I'll show you a video of how we get Raffaello from the payload bay onto station, if you can roll that video. This will be the morning of Flight Day 4. Our robotics operators, Sandy Magnus and Doug Hurley, will be located in this cupola on the space station where you see the blinking windows. They have the controls there to drive the station robotic arm, the Canadarm2. They'll move in and grasp the MPLM and carefully extract it from the payload bay. This is the view that Doug and Sandy will see when they're working in the cupola. You can see they have good views out the window. They also have closed circuit TV that they'll be using. They'll maneuver the module up to the node 2 or Harmony node the earth-facing port there. They'll maneuver it into position so that the common berthing mechanism latches just a few inches from the interface. That there will be 4 latches that will grab the module and will pull it in to connect the MPLM to the station. Then the crew will drive 16 bolts to secure the MPLM and get an airtight seal. After that, Sandy and Doug will maneuver the arm to the start position for EVA the next day. So after the MPLM is firmly attached to the station, the crew will go into node 2 and they'll open that lower earth-facing hatch. Then they will perform what we call vestibule outfitting. They'll connect the electrical, data, and power jumpers so that they can activate the MPLM. They'll also install air ducting, and then they'll actually open the hatch, go into Raffaello, and begin the cargo transfer process. Meanwhile, our spacewalkers for the next day, Mike Fossum and Ron Guerin will be working with Rex Walheim, transferring the cargo that they need for the spacewalk from the middeck of Atlantis into the space station. They'll be doing their final tool verification, and then at the end of the day, the entire crew will have an EVA conference to review the timeline for the EVA. So that takes us to Flight Day 5, and the focus of Flight Day 5 will be the EVA itself. Just to give you a little bit of background on how we're going to conduct this will be the first shuttle mission where the EVA is performed by the space station crew. The reason we did that is because with a small shuttle crew of 4, we wanted to offload the training tasks on the shuttle crew and sort of level the load. So we took advantage of the EVA experience of Mike Fossum and Ron Guerin. As I mentioned before, they've actually done 3 spacewalks together on a previous shuttle mission. So Mike and Ron together were able to get up to speed very quickly on this EVA, and that way we relieved the shuttle crew from having to also add that to their very busy training schedule. Now, during the spacewalk, again, it'll be Mike and Ron going outside, but supporting them in the space station will be, again, Sandy Magnus and Doug Hurley driving the station robot arm to support the EVA. Chris Ferguson and Satoshi Furukawa will be assisting with Mike and Ron getting in and out of their suits before and after the EVA. And Rex Walheim will be on the aft flight deck of Atlantis, overseeing the EVA and providing the EV crew members specific instructions and choreography on the EVA as they go through the 6.5-hour spacewalk. Just to give you an overview of what the primary objectives are, we are going to return the failed pump module. It's an ammonia pump module that supports the space station external thermal control system. This failed back on July 30th last year. I remember because I was on console when it failed. It was one of those moments where on a quiet Saturday and the crew's off duty and getting ready to go to bed and everything's going real well, and then it all changed in a second when that pump module failed. All the caution and warning started going off, and the ground and the crew had to very quickly scramble to reconfigure the systems and power down some of the systems in order to keep the shuttle limping along on one remaining cooling loop. We have two cooling loops on the space station. So that was a major failure in the history of the space station program. It was the first major failure that required spacewalks without a shuttle present to fix the problem. It actually took 3 spacewalks to remove the failed pump module and install the new one. And that was actually, those spacewalks were actually led by one of the flight directors on our team, the Orbit 3 flight director, Courtney McMillan. So on STS-133, just earlier this year, that pump module was moved into position on external stowage platform number 2. It has been vented of all its ammonia. It's now an inert payload, essentially, that will be brought back on the shuttle, and we'll be very interested to see, to examine that and to see what exactly was the failure mechanism. We do have spares on orbit still, but we do want to understand what happened with the pump module. Our next major objective with the EVA, as Kwatsi mentioned, is to install the robotics refueling mission. We can roll that video. This is, again, it's a technology demonstrator to demonstrate the techniques and the tools and the procedures that will be used to perform in-flight refueling of satellites. What we're going to do during the EVA is the crew's going to remove it from that LMC bridge. They're going to install it on the outside of the station. And then over the next 2 years, our SPDM, our special purpose dexterous manipulator, or Dexter, will use the tools there in RRM to practice and demonstrate the techniques to perform orbital refueling. There's even a simulated liquid fuel system in RRM that Dexter is going to actually use to transfer fuel between tanks. Another objective of the EVA is to install the ORMATE stowage platform. ORMATE stands for Optical Reflector Materials Experiment. These are samples of various optical materials, and scientists want to understand how exposure to the space environment affects those materials. This actually went up recently on STS-134, but because its mounting location is close to the AMS, the alpha magnetic spectrometer, there was a concern that the insulation on AMS could, as it outgasses for the first couple weeks on orbit, it could contaminate these samples. So the decision was made to delay the installment until the flight of Atlantis. And we have a few what we call get-ahead objectives on the EVA. These are things that if we have time available at the end of the EVA, we will perform. Our top priority get-ahead item is installment of a thermal cover on the PMA-3 port that's shown in this graphic. There is the thermal cover would fit over the mouth of that PMA, and what the purpose of that is to shield a pressure equalization valve on a hatch on PMA-3. This hatch, when it's exposed to direct sunlight, overheats and it's degrading the seal life, and it could eventually lead to an air leak in the PMA. So we want to get the thermal cover in place to provide a more favorable thermal environment. And another get ahead, if we have time, will be to complete the activation of a power and data grapple fixture on the FGB or Zarya module. This work was started on the recent mission STS-134. A couple of outstanding tasks are to complete the data and power jumper mating so that this can become a usable base for the station robotic arm. There was also a problem identified where there appears to be a wire in one of the capture latch doors, and that's shown in the next figure there, circled in yellow. The crew is going to go in and clear that wire out of the way. Again, so we have a new base for the station arm. As you know, the station arm can walk around station sort of like an inchworm, and it uses these PDGFs as basing points where it latches down structurally, and it has electrical and data and command interfaces so that it can be driven from any of those locations. So later this morning, you're going to get a brief from our lead EVA officer, Glenda Brown, and she's going to fill you in on all the details of the spacewalk. That takes us to the end of Flight Day 5. Flight Days 6 through 9 are going to look very similar. Those days are focused on the heavy lifting of the cargo, moving all the cargo out of the MPLM into the station and then repacking it. That process basically involves every day the crew is going to wake up and they'll have received from our teams working overnight, they'll receive a transfer list that tells them specifically which items to transfer, where they're located in the logistics module, where each of those parts go on the station. We keep very careful track of where material is stowed on the station because it's with an internal volume the size of a 747, it's very easy to lose things. They'll also be performing some maintenance type tasks. For example, we hope to install the ultrasound and all the supporting hardware that goes with that in the space station. And also a couple of unique items that I'll just call out on Flight Day 6. That's the day where we will perform focused inspection if it's required. Quatsi had mentioned that we'll perform the R-bar pitch maneuver during rendezvous and also the Flight Day 2 inspection. If there are any areas of concern, we can go in and on Flight Day 6, we can go in and use the orbiter boom sensor system to closely inspect any areas of concern and determine whether it's safe to land with the damage or whether we need to send the crew out to repair it via EVA. Flight Days 7 and 9 will each feature a few hours of off-duty time in the afternoon, and Flight Day 8 will do a resize of one of the spacesuits on the space station and then bring it back in the shuttle to Earth. We'll rotate one of our spacesuits from the space shuttle up to stay on the space station. Flight Day 9 is our last full day of MPLM cargo transfer. The important thing on that day will be to make sure we've gotten everything off the MPLM, to make sure that it's properly loaded with the return cargo. We have literally tons of cargo coming back. It's important to make sure that we get the right CG and loading for that MPLM on the way home. And we're bringing back things such as trash, obsolete parts, equipment that can come back and be refurbished and reflown, as well as science samples. So just to run down some of the numbers there on cargo return, we expect the MPLM to weigh 21,500 pounds for the trip home, and our total return complement is 6,300 pounds. And we can go ahead and roll the video, and I'll show you the process of unberthing the MPLM towards the middle of flight day 9. Of course, we'll get the hatches closed. Again, Doug and Sandy will be back in the cupola. They'll drive the bolts to release the MPLM. And they'll carefully maneuver it into the payload bay of Atlantis. And this will actually take place on flight day 10. Also on flight day 10, in addition to restowing the MPLM, we'll be transferring our science samples. We're bringing back a lot of biological samples that need to be kept cold, so those will be coming out of the station freezers and put into freezers on the Space Shuttle flight deck. And again, flight day 10 is a real busy day just to make sure that all the transfers are done correctly. We got everything on the right side of the hatches. And then the crew will say farewell and close the hatches that evening. And with the departure of Atlantis, the focus on the station will switch from assembly ops to utilization. And again, the type of science that we'll be doing on the space station has a lot of applications to folks on Earth. I mentioned the ultrasound, and we're also examining the effects of weightlessness on the immune systems of the astronauts. We've noticed how their immune systems are compromised by spaceflight. We don't understand the mechanism. It's a very important area of research that will continue on the space station with obvious applications for people on Earth. And again, with our advanced life support system, we're working towards closing the loop to reuse all the water on the space station and not waste anything. With our advanced recycle filter tank assembly, we're getting very close to being able to recycle urine indefinitely with very minimal resupplies. And we're already at the point now, we've got carbon dioxide scrubbers that are operational on station that require no throwaway parts. They're completely regenerable. And that means, at least for carbon dioxide and for water, we are getting very close to the point where we can leave low Earth orbit and go for an extended time into interplanetary travel while recycling those critical life support functions. And so I fully expect in the next 30 to 50 years, when spaceships are leaving low Earth orbit, they'll be using the systems that we've demonstrated on the space station. So that's the legacy of the Space Shuttle, and we're really excited to end this mission on a high note. So I'll hand it back to Quatsi for the remainder of the mission.
Thank you, Chris. As you can tell from this very thorough description, that we do have a lot of work to do during the docked phase, but at the end of flight day 10, the crew of Atlantis will be buttoning up the spacecraft and preparing for undocking the next day. That preparation will include installing the centerline camera into the orbiter docking system, as well as maneuvering the orbiter boom sensor system into its undocked position, and doing the rendezvous tools checkout that'll be required for the next day's undocking and fly around. Very early on flight day 11, Atlantis will release hooks and undock from the International Space Station for the very last time. She'll perform a modified fly around, which we're actually very excited about this. Normally, the shuttle will undock from the International Space Station and fly around the space station taking photographs in the undocking orientation. But what's going to happen this time is Atlantis will hold at about 600 feet away from the space station while the space station performs a 90-degree yaw maneuver. And we have a video of what that looks like that we'll show you. What this does for us is this allows us to present a side of the space station that the shuttle does not normally get to see on undock and fly around, so that the crew can take high-resolution engineering quality photos of sections of the spacecraft that we have not seen before on fly around. This will enable us to evaluate other areas of the space station for micrometeoroid and orbital debris impacts, as well as assess the overall health of those parts of the spacecraft. After that half-lap fly around, Atlantis will set and go on her merry way while the ISS maneuvers back to its normal attitude. We'll then prepare for the final TPS inspection of the mission, and that's what we call our late inspection. In this case, the mechanics of the late inspection are identical to that of the Flight Day 2 inspection that you saw earlier, but in this instance we're looking for signs of micrometeoroid and orbital debris damage, and we do have an animation of the late inspection that we'll show you. Again, much of it should look very familiar in that we're going to use the orbital boom sensor system to start with a high-resolution scan of the starboard wing, looking for any damage that might have occurred during the docked phases while we were doing all of our logistics and resupply, and even during the spacewalk. This helps give us a final sense of comfort and assurance that Atlantis' TPS, or thermal protection system, will be in good shape when we prepare for her final deorbit and landing. We'll inspect the starboard wing first, then the nose cap, and then finally the port wing, as well as selected areas around the payload bay doors and the umbilical interfaces. Again, looking for any last-minute issues that we might need to address before we prepare for landing. The very next day on Flight Day 12, the big item that we've got there is the deploy of the Picosat solar cell satellite. This is a very small satellite. We have a photo of it for you. And essentially, it's a DoD payload. We've done these before. Essentially, it's got a series of solar cells that power some antennas and some other maneuvering systems on that satellite. We also have an animation of the deployment. We'll maneuver the shuttle into its deploy altitude and its deploy attitude. The animation, which we'll show you here very briefly, shows the canister that I illustrated to you earlier. The satellite will be released from the canister mechanically, float just above the OBSS, and then move away. Following the deployment of that satellite, the shuttle Atlantis will execute a small maneuvering burn to maneuver the shuttle out of the way so that we don't recontact that satellite on the following orbit. And then we'll prepare for our standard landing minus 1 day activities, which include a checkout of the flight control system, checkout of all of the reaction control system jets. We'll stow the KU band antenna and basically prepare Atlantis' systems for deorbit and landing, which will occur on Flight Day 13. That'll be our final deorbit and landing, hopefully to Kennedy Space Center if the weather holds out. But of course, as always, we have other landing opportunities, which Entry Flight Director Tony Sakachi will talk to you about in the coming days. So in conclusion, we're expecting a very busy mission. We think it's going to be an exciting mission. There are obviously a great sense of mixed feelings surrounding this final mission of the Space Shuttle program. I know I personally feel very humbled and honored to be part of the Space Shuttle program and to be part of this mission in particular. I was in 4th grade when Space Shuttle Columbia launched on its very first mission, so it's actually quite an honor to be the lead flight director on the last mission of the Space Shuttle program. You know, to me personally, the shuttle was one of the things that inspired me to want to focus on math and science while I was in school. I actually decided when I was in 4th grade, after watching the launch of Space Shuttle Columbia, that I wanted to be an engineer, and in particular that I wanted to go to MIT to study engineering. Of course, many of the managers around here would tell you that I didn't have enough sense to want to go to Texas A&M, but I think I did okay. Although MIT isn't cool enough to get a space shuttle simulator, my alma mater does do the analysis that allows the shuttle to maneuver in space. So for me personally, I consider this a great honor. I consider it a great honor to work with the flight controllers that have been detailed to me on my team. We have people of diverse backgrounds and diverse skills and capabilities. They're some of the finest engineers in the country, some of the finest engineers that I've worked with, and I can't think of too many more places I would rather be than in the Space Shuttle flight control room, leading those troops into a fierce battle with gravity one last time. And so we very much appreciate what the shuttle program has done for us, the national capabilities that we've gained through it, the knowledge that we've gained through it, and are looking forward to transitioning to the next things that we'll focus on. I do not at all in any way, shape, or form view the end of STS-135 and the end of the program as the end of human spaceflight. I think that's would be rather short-sighted of me, reflecting on the incredible spacecraft that we've been able to build in the International Space Station, and we have the capabilities to go further with different national visions. As Mr. Shannon alluded to earlier, there is limited money, and so in an era where you have limited money, any enterprise, any portfolio of programs that claims to be advancing the cause of human spaceflight is going to be filled with endings and filled with beginnings. And so the challenge really is for us to end in a manner that is respectful of the dedicated professionals that have contributed to the cause, and to begin in ways that set us up for long-term success. So STS-135 is, in my view, an important first step in an important transition in our national vision for space. And so I'm privileged to be a part of it. Mr. Edelin and I are very much looking forward to getting after it here in a week or so. And at this point, I'll turn it back over to Rob.
Thanks, Quatsi. Thanks, Chris. We'll take questions here in Houston. We'll start over on this side, just sweep across as is customary, and then we'll go to the other centers. Start off with Bill Harwood.
Bill Harwood, CBS, with two quick ones, I think, both for, well, maybe one for Quatsi and one for Chris. First, is the chance of an extra day a long shot for this mission, or is that something, if you get off on time, you think you've got the margin to do? And for Quatsi, I think the media is focused on KSC with people losing jobs there because the numbers are bigger. But obviously, the Space Shuttle Mission Control Room, this is it. And can you give us a sense of what happens to the team that's been supporting Shuttle from a mission control standpoint, and how many of those can transition to station versus just going to have to walk out the door?
Okay, those are both excellent questions. I can address both of them. First, a question about the extra day. The nominal mission duration for STS-135 is 12 days, and that's not including the contingency days that we keep in the bank as a reserve to address weather issues or other systems issues. Now, we are flying with full cryogenic tanks. Our cryogenic oxygen and hydrogen tanks are used to generate electrical power, which is the limiting consumable that drives how long we can stay on orbit. Based on our analysis and based on the power requirements for this mission, we are approximately 80, give or take, kilowatt hours away from having sufficient margin to extend from 12 days to 13 days. Now we've assessed some options for making up that deficit. One option that we've discussed with the ISS program and that we've agreed to is that if we do launch on time, we will not power the heaters that are used to keep the MPLM warm in the payload bay. We won't power them between flight days 1 and flight day 4, where we install the MPLM, and we won't power them after we unberth the MPLM and bring it home. We've done analysis which suggests that the temperatures can be maintained within acceptable limits without those heaters. Those heaters really provided additional capability and redundancy. So by not powering those heaters, we're going to save most of the power that we need to save in order to make up that extra day. The remaining deficit, which is to the tune of right around 25 kilowatt hours, we think we can make that up with essentially what we call a cryo overload. When we're loading the cryogenics, the oxygen and hydrogen into Atlantis just prior to launch, typically when we top it off and fill it up, there's just that little bit extra that we're able to get in the tanks above and beyond the spec volume of the tanks. We call that sort of our cryo overload. And historically, we've seen a consistent trend of how much additional poundage, if you will, of cryogenic oxygen and hydrogen we get. If we get what we have seen typically, our analysis says that will make up the remaining deficit. So a combination of cryo overload and not powering the MPLM heaters, we think that's going to get us there if we launch on time. If we don't get the cryo overload that we expect, we might be able to make up that deficit with some very modest additional power downs. Again, nothing that's critical that we would need during our travel to and from the space station, but just turning down the lights when we don't need them, that sort of thing, the typical type of power conserving measures you would use in your own home. So we think we're actually very close to getting it if we get off on time. Now, what's magic about getting off on time is with these cryogenics, of course, they are super cooled fluids. And even when the shuttle's fuel cells are not powered, these fluids don't stay super cooled for long, and there's a certain amount that boils off and escapes, if you will. And we know how that process works over time. And so if we launch late, the amount of cryogenic oxygen and hydrogen that's in our tanks, say a day late or 2 days late, is measurably less than it was on the very first day that we topped off. So a critical enabler to us getting the extra day is going to be launching on time on July 8th. But we think we'll have that. We think we'll probably have that in the bank. And what we'll do to assess that is we're not going to commit to the extra day as soon as we launch on time. We're going to get off on time, hopefully. We'll choose not to power the MPLM heaters as I described for you. And then we'll watch the performance of the electrical system on the shuttle for about a good 4 days just to observe how our margins are increasing. We have very good insight into that. And then we'll make a decision or ask for a decision from the mission management team right around flight day 5 if we have seen the performance that we expect to add the additional day. And we'll put the additional day's worth of content in the nominal timeline between flight days 8 and flight day 9. And the content of that additional day won't be too mysterious. It'll be more cargo transfer. It'll enable us to get down some additional pieces of equipment that we weren't expecting to be able to get down, and also dispose of some additional trash. So hopefully that gives you the information that you need about our plans for trying to extract an additional day out of the mission. Now, as it pertains to your second question about what's going to happen to the flight control teams, I have a considerable insight into the disposition of members of my team. In addition to staying focused on making sure that this mission is accomplished successfully and with the same diligence and the same vigilance that we've put into prior missions, I'd say my next greatest concern and area of focus has been on what's going to happen to my teammates and making sure that they're going to be okay. My observation is that the management of our contractors who support the flight control team has spent considerable time and effort to assist those individuals who don't have jobs after the end of Shuttle, to assist those folks with career development by offering services, career placement services, assistance with building resumes, and really providing as much assistance and support as they could. The feedback I get from members of my team is that they feel like they have been well helped. There's a mix of stories on my flight control team. The people who report to me directly, there are some individuals who right now have already been identified as very strong candidates for certain disciplines on the space station flight control team, and they'll have the good fortune of transitioning to those jobs right after we conclude the final mission of Atlantis. There are some members of my flight control team who have actually looked for and found jobs prior to this launch. We've had some change out and some turnover on my team in the last 6 months because there were some folks who actually had interviewed for jobs and they were fortunate enough to get some and they started before the flight of this mission. We even have some folks on my team who have been selected and have gotten jobs that they will be able to start after this mission. So they'll be able to carry out STS-135, and after STS-135 they have different jobs outside of NASA and outside of space industry to go to and be able to start a new career. And then, of course, on the flip side of the coin, there are individuals who, at this hour, do not have specific plans or job prospects after wheel stop on STS-135. So there's a mix of successes and a mix of works in progress with respect to the disposition of the personnel who are going to be supporting.
Tracy.
Tracy Watson, USA Today. Can you talk about how the Flight Day 2 inspections and the docking will accommodate the smaller crew? What tweaks have you made? Where have you squeezed out the time and the tasks?
That's a great question. There's an expression among the management ranks that there is absolutely no substitute for having really smart people working for you. The folks who are doing the planning for this mission, we gave them the challenge early on to try to figure out a way, if possible, that we could get this crew to the International Space Station in 3 days. That was critical because, as you know, Atlantis is not what we call a Spitz-capable spacecraft, so we don't have the capability to feed Atlantis's power systems from the International Space Station, so we have a very limited window of time in which to accomplish this mission. However, we were also flying up one of the heaviest and fullest MPLMs that we flew, so getting to the space station on Flight Day 3 was going to be a critical enabler for the core purpose for which we're flying this mission. As you've probably heard from us in times past, particularly when we were doing early assessments for STS-133, that in the post-Columbia era, where we have all of these TPS inspections that we have to do between launch and docking, with the reduced crew complement, we really were struggling to find a way to connect the dots, if you will, in a way that respected all of our constraints for scheduling of the crew day. What we were able to do was actually find some efficiencies on the day of launch that are not always visible and that are largely unknown to many. On the crew's launch day, we typically wake the crew up several hours before we begin preparation for them to get into the shuttle and actually launch. And then after launch, we tend to keep the crew up at for about 6.5 hours. So on these missions, typically the crew will go to bed at about 6.5 hours after launch, and that makes for a respectable crew day that doesn't overly tax them. Well, the feedback that we've gotten from recent crews is that this time period between wake up and earnest preparations for launch, which in their pre-flight timeline is called crew study time, that most of them don't really use it for crew study. I mean, honestly, with as much as we rehearse these missions and simulate them and train them, the crews usually on the day of launch are very well familiar with what they're going to go do. And so they typically have not utilized this time fully. Our planners had the bright idea to basically wake the crew up later and essentially dispose of this underutilized time, so that we could then keep the crew up in space later and put them to bed at about 8.5 hours, vice 6.5. And so that allows us to accomplish more activities in space while still putting the crew to bed at the same time relative to when they woke up that they normally would go to bed. So it's completely compliant with all of our medical requirements for the length of a crew day, but essentially we traded some unused time on the ground for some very badly needed time on orbit, which has allowed this reduced crew size to accomplish all of the critical path activities on Flight Day 1 that then had a waterfall effect that enabled us to complete all of the activities we needed to complete to rendezvous on Flight Day 3.
Questions? Let's see. Let's go to Marcia here in the middle.
Marcia Dunn, Associated Press for QUATSI. I was wondering, how many total team members do you have that you've been describing? And out of that, what percentage are still without job plans? What happens to you? Do you go back to station ops? And are you going to Kennedy for the landing, as so many flight directors have done in the last few flights?
Okay, those are all good questions. I would say the percentage of my team members who are contractors that do not have jobs after the mission, I would say that's maybe about a quarter of them, about 25% of them. one of the things that influences that is that some of my team members are actually civil servants. Most of them are contractors, but many of them are civil servants. So I'd say there's maybe about a quarter of my team right now that are still working on finding jobs for post-flight. As far as whether or not I'm going to go to Kennedy for the landing, that's a good question. Interestingly enough, my boss asked me the exact same question 2 days ago. I'm still thinking about it, honestly. On the one hand, it would be an awesome thing to go to Kennedy for the landing. And I've actually never been to see a shuttle landing. Interestingly enough, I've never seen a shuttle launch. So that's a great opportunity. On the flip side, given that this is the last shuttle mission, there's a part of me, and those that know my personality and know me would appreciate this. I feel a very strong desire to end my career as a shuttle flight director exactly the way I've lived it, which is in mission control, making myself available to be useful if needed. And so I'm still thinking about it, honestly. I don't know. And as far as my expectations for what I'll be doing after this mission's complete, as you already know, I actually grew up on the space station side. Although I've had an exciting career as a space shuttle flight director, space station's the vehicle I was born on, if you will. It's the vehicle I grew up on. I started my flight director career as a space station flight director. I still support shifts routinely as a space station flight director. So for me, personally, the transition is not as stark because, shortly after wheel stop on STS-135, I'll probably see a schedule with my name listed on it for an integrated simulation in the space station training room or shift in the space station flight control room. So as far as transitions, my thoughts tend to be centered around the members of my team. As I said, when I think about this mission, what I think about the most are those people that I work with, my teammates, those with or without jobs. It's the thing that fills me with the most pride and a sense of satisfaction is being associated with that tremendous group of people.
Mark?
25% of home. How many people are you counting in that mix? Total team number.
For the people who are detailed to me, I'd say on the order of a dozen to 2 dozen. And that includes the people that you see in the front room as well as their backroom support personnel.
Mark Kirkman, Interspace News. It's actually for both of you. Since you're going through all the extra trouble of get this extra angle on the undock fly around, what's preventing you from going at least the full 360, and what do you lose by not going that extra quarter rev back to the R-bar?
Thanks. Want to take that?
Yeah, the purpose of doing the modified fly around with the station yawing essentially 90 degrees is to be able to image the sides of station that we don't normally see. So with the shuttle out on the front of the velocity vector starting the fly around, we'll be able to get images of the plus Y or the right-hand side, the starboard side of space station. Then as we fly over top to the back side, we'll be able to get pictures of the minus Y or port side of the station. So essentially, we effectively can image the sides of the station that we're after on the modified fly around. We don't need to spend any additional time flying around the underside. We get plenty of views of the underside of station when we come up to dock. We get plenty of photographic documentation there to look for any damage, as Quatsi mentioned. So we can accomplish this in just half a lap. There's no need to spend any more crew time. Flight day 11, the undocking day, is extremely busy, as Quatsi described, because after they undock and do their separation burns, the shuttle crew is going to be jumping into their late inspection to make sure that the thermal protection system is safe for landing. So it's a very busy day, and we don't want to waste any time.
Philip Sloss with NASASpaceflight.com. I had a couple questions for Mr. Albarujo first. The ET camera modification that you're doing, are there any expectations about what we might see downrange after Wallops loses the signal from the tank?
That's a good question. I think right now we don't know what to expect, and the modifications he's referring to is that the camera that's mounted on the external tank will continue transmitting longer than it normally would after it separates from Atlantis. We're not going to be looking at that imagery on board Atlantis. That's going to go straight to ground stations, and I don't think there are any specific expectations about what they'll see. But since we will see images from that camera much longer than we have in the past, we're interested to see what we do see. There might be something that we learn from that imagery.
And then for Mr. Edelin, could you just, I guess, clarify that you said that the MPLM upmass is second heaviest, but that the cargo is the heaviest, if I heard you correctly. Is that just a difference between Leonardo and Raffaello in terms of their dry weight?
That's correct.
Okay, thank you.
And also it also pertains to the support equipment inside the module that holds the cargo.
Jim Oberg with NBC News. For both of you, you're all looking at the mission, but what kind of thoughts do you have in terms of end of mission ceremonial transfers or events, things you want to make sure you remember and people you make sure you remember at the end? Do you have anything in mind, or are you gonna work that out pretty much in real time?
Well, that's a good question. Of course, at the end of this mission, one of the things that's traditional is that we have what we call a plaque hanging ceremony. In mission control, as you've probably seen on cameras, we have plaques that are made in the image of the crew patches for the mission and the program patches for the mission. We award those plaques to the individuals or disciplines that we feel most significantly contributed to mission success for each program, one for Shuttle and typically two for Space Station. I think this plaque hanging will be a particularly poignant one. In that there'll be certainly a lot of emotion that I think will be surrounding the final Space Shuttle, Space Station assembly plaque hanging. There will be other ceremonies like that. As I said before, we're certainly not ending human spaceflight, contrary to what some have said. The space station will continue missions. There'll be a continuation of resupply missions as well as crewed missions to the space station and the traditional ceremonies that go along with that. But I think that the focus will be to make sure that we appropriately honor those people who have not only contributed to this mission, but to respectfully honor the contributions of those who've enabled the success of the shuttle program, all the things that we've learned in the shuttle program. The capabilities that NASA has today. And when I talk about capabilities, I'm talking about capabilities of knowledge, things that we know how to do. These capabilities are the result of fiscal investments that have been made in these programs. And they're also the result of investment of lives and life's work. And so the focus will really be on appropriately honoring that and the people who contributed. As far as additional ceremonies, I think there'll be many more that we'll do in the coming days. One thing that I think is worth emphasizing is that this team and the people here at Johnson Space Center have not been tremendously focused on this flight as the last flight. The prevailing sense that I get from all of the people supporting this mission, from the program office personnel who are putting together the requirements and making sure that the hardware is fit, to the people on my flight control team who are preparing to execute this mission. The prevailing sense and the prevailing desire is to fly this mission safely and successfully, because we think that is the most powerful legacy that we could leave for this program. And so, one of the side effects of that is that we really haven't thought as much about commemorating lasts and finals and ends as you might think.
Alan?
Alan Boyle with MSNBC. I wanted to ask how the flight directors will transition to the commercial resupply and eventually crew transfer era. Is there going to be a fundamental change in the way that you're going to be doing your job or in the way that your teams are going to be organized?
That's a great question, and let me apologize in advance for the answer, but it does have the tremendous virtue of being true, which is I don't know. We haven't gotten far enough along in the development of those programs for there to exist a cogent answer to that question. What I can tell you, though, is that we have a very strong flight director corps. The vast majority of us are qualified on International Space Station. Most of our space shuttle flight directors, minus 2 or 3, are also space station flight directors. So for us, we will continue to serve in the role that we have historically played with respect to the International Space Station program, and also serve in leadership roles, leading the development of the operational philosophies and the interfaces to the commercial providers. As far as who will actually provide tactical, real-time command and control and operations of those spacecraft, those are things that I think are still being discussed, and there are a variety of models that may work. And I think if you ask that same question again in another year, you'll probably get a more detailed answer to that.
Right. Just quickly, does the Russian mission control model provide one of those models? Would it work that way, where you have separate commercial and space station, for example, mission controls?
I think the Russian flight control model is one model, certainly. In my personal experience working with the Russian teams, there are some obvious strengths of that model. It seems to work for them, but it may or may not be the right tool for this set of companies with our culture and our capabilities and our core rigidities. So that's something that folks are going to be looking at. The Russian model does provide us an example to evaluate, but I'm not 100% convinced that it'll evolve to look exactly the way the Russian teams look.
Additional questions here? Let's go in the front, Denise, and then Gina.
Denise Chow at space.com. Just to follow up with Tracy's question, because there are only 4 members of the shuttle crew, are you anticipating that they'll have or face a lot more stress or pressure, not just on inspection and docking days, but for the rest of the mission with the cargo transfers and everything?
Okay. Question about additional stress and pressure because of the reduced crew size. One thing that I've observed from this crew, in addition to their incredible resumes and portfolio of skills, is this is a crew that works very, very well together. I tell you, just as far as the personalities involved, this is a very this is a crew that's got, I believe, an incredible joie de vivre, if you will. They enjoy what they do. They enjoy working together. They enjoy each other. And so what I've been most impressed with from this crew is how they've examined all of the challenges that they have, and they've simply put their intellects and their skills to work at finding solutions and to those problems and mitigating those challenges. As I've worked very closely with Commander Chris Ferguson over the last several months, he's great at highlighting to me issues and things that they are concerned about, but he doesn't very easily display worry in the traditional sense that you may think of people worrying. So this is a very confident crew. They're very competent. And we're going to do our part on the ground to keep things as stable for them as possible, so that they can field the challenges of this mission, even though there are fewer number of them. And I believe they're really going to be fine, and they're going to do great. I've got just tremendous admiration and respect for this crew.
Gina.
Gina Sinceri, ABC News for Chris. 2 questions. Got a lot of stuff going back and forth. So what was your secret? Post-it notes, barcode scanners? How do you keep track of everything going back and forth?
Well, we use color coding, believe it or not. The things that are to go up into the space station and be left there are typically colored with a yellow label. The crew remembers that. By yellow means it goes towards the sun. And the items to be brought back to Earth have a green label going back to the grass. The food, that was done by a different group, and it's blue labeled, but we all know all the food is going to end up on the station The colors help the crew to keep track of where things go. Each item is also labeled with specific location label codes and part numbers and serial numbers, and we keep track of all that in a database. That's one of the functions we performed here in Mission Control Houston, keeping track of where everything is located, and we'll follow closely what their crew reports at the end of the day. Sandy Magnus will call down and report which items in her transfer list were stowed. We have the same list on the ground, and we'll enter all that into the database.
And for Chris, I imagine that, it was very competitive getting something on the going up list. Was there anything that you would have liked to have gotten on that list that you didn't? Was there a last call for ideas?
Actually, food is always something we need more of. But the space station program actually did a phenomenal job, because when this mission was first identified as being this was really going to happen, that was about 9 months ago. Initially, the folks in the space station program said, we can't possibly have enough cargo to fill up a logistics module. We just can't get it together in time, because the spare parts have to be manufactured and inspected, the food has to be produced, and there's a long supply chain that has to take place, and the material has to, it can't be ready just on launch day. You can see that it, from the video there of the work at Kennedy Space Center, it takes several months to load up an MPLM, and it has, the cargo has to be processed even before that. So it was a huge challenge, and the space station program really rose to the occasion, and Mike Suffredini is very pleased that we were able to literally fill up the MPLM. It's as full as it can be, as you saw from that video.
Any last questions? We'll take one more from Irene, then close it out.
Thanks. Irene Klotz with Reuters, for either one of you would like to answer this. What's your biggest concern about not having shuttle for station logistics support?
Well, the biggest concern about not having the shuttle available in the future is the unique capabilities that the shuttle provides, bringing up really big stuff, big spares that can't fit, for example, in the trunk, which is the external stowage location of a SpaceX Dragon, for example, or the items that come up on a Progress freighter. Those have to fit through the relatively small Russian hatch. So that's the big concern, is bringing up large spare parts. And also, the shuttle provides a lot of down mass capability. I described how we are bringing back over 6,000 pounds of cargo on the shuttle return. Now, these concerns have been addressed through the design of the other robotic spacecraft that will be servicing space station. I mentioned that SpaceX can carry moderate-sized spares in its trunk. The Japanese HTV also has an external cargo platform. It can bring up spares. And we've also made a strong effort on the station program to pre-position lots of spares. For example, the pump module that failed, we have 3 pump modules already up on the outside of station, stored as spares, and we'll plug them in as needed. So we've really looked ahead to try to see what capabilities we lose with the shuttle, and to try to adapt to that.
Okay, that'll wrap up the questions. Or actually, no more? One more. Just one more.
Philip Sloss with NASASpaceflight.com again. Just to follow Denise's question earlier, is there anything that the flight control team can do on the ground to reduce some of the crew work on orbit?
Well, there are a few things. The first and most important thing that we can do to reduce some of the crew work is to make sure that the procedures and documentation that the crew has are correct. Rework, is a fact of complex spaceflight, but minimizing that would really help the crew. My flight control team has done a great job of looking at things that might need to be different in our procedures as a result of the reduced crew complement, and I think we've got a pretty good handle on that. On the space station side, one of the great things about space station is that those core spacecraft systems are largely operated by the mission control team, and so offloading the crew from a lot of the systems commanding and systems operation that they have to do with the core spacecraft systems, that also helps quite a bit. One of the things that one of my flight controllers is going to do, my communications and instrumentation officer, she's going to operate all of the cameras for the crew. Many times the crew would pan and tilt their cameras as they're doing their robotics tasks for unberthing the MPLM or maneuvering spacesuited crew members from one part of the space station to another. We're going to run the cameras for them, again, to essentially provide an extra set of hands from the ground. So these are just a few things that we'll be able to do.
All right, great. That closes out the questions for today. Quatsi, Chris, thanks very much. Just a couple of programming notes before we close. Coming up next on NASA Television, the NASA TV video file out of headquarters with agency-wide news and video. And then that'll be followed at noon Central Time, 1 p.m. Eastern Time by the STS-135 Spacewalk Overview Briefing. An hour after that at 1 p.m. Central Time, 2 Eastern, the final pre-launch news conference for Atlantis' 4 astronauts, so you'll want to stay tuned for that. You can follow everything associated with the final flight of the Space Shuttle on our website at www.nasa.gov. Stay tuned as coverage of the STS-135 pre-flight briefings continues on NASA Television. Thanks very much.